Next decoding. Yeah. That is, suppose vector x is received. Yeah. Vector x received is decoded to Cx. Yeah. If the distance between x and Cx is minimal. Yeah. Minimal along all the distance between x and the other code word. And the complete and incomplete version in this decoding rule are analogous to maximum likelihood decoding. Suppose you have an example like this. Yeah. C is a code of size 4 and the length is 5, and we have a word, a vector that are received by the receiver is 0, 1, 1, 0, 0. And how we decode this vector? First of all, we try to find the distance between this vector to all the code word. You know that the distance that is 1, 5, 4, and 5. So the distance, yeah, the smallest distance is 1. Yeah. So 0, 1, 1, 2, 2 is decoded to 0, 0, 1, 2, 2. Yeah. Because the distance among from 0, 1, 1, 2, 2 to this has a minimum distance at the distance between this one and this one. So whenever P is less than 2, then MLD is the same as nearest neighbor decoding. Yeah, the rule of MLD is the same as the rule on the nearest neighbor decoding. And this is the background for the ring. I think we are all already known the ring. Yeah. This is modular arithmetic, that is Zm is integer modulo m. And this is the relation of ring and the integer modulo rank. Yeah. Zm is filled if only if m is prime. And then characteristic of ring. Suppose we are given field f, and then the polynomial ring over f is given the set of summation of ai x to the I, where I run from 0 to n, where n is integer greater or equal to 0, and ai is in f. An element of fx is called the polynomial over f, and the degree is the largest n such that the an is not 0. The coefficient of an is not 0. The degree of 0 polynomial is said to be minus infinity. A polynomial fx is not 0 of degree n is called monic if the coefficient of x to the n is 1. And positive degree polynomial fx is reducible over f if there are polynomial gx and hx such that fx is gx times hx. Otherwise, we call it Fx is irreducible. This is the example. Yeah. This is Fx is x to the 5 minus 1. Yeah. In F 13, that is in the base field is a field of 31 element. Then x to the 5 minus 1 can be written as this. This is just algebraically. This is the remainder, LCM and so this is the relation between integer and the ring polynomial of Fx. So in integer, we have an element of integer m and polynomial Rx. There is a Fx that is polynomial in Fx. An integer is prime is an in the ring of polynomial, we have a polynomial is irreducible. Yeah. The operation is like this. I think we can skip off the finite field. This is the definition that can be used in the next lecture, I guess. The minimal polynomial of an element alpha of Fq to the m with respect to Fq, with m is an integer, that is a minimal polynomial is non-zero monic polynomial Fx of least degree having alpha as a root. Yeah. And the properties that the minimal polynomial of alpha with respect to the Fq always exists, and it is unique and also irreducible. And this is a cyclotomic coset. I think we can skip this. This is a primitive element. Yeah. And then this is a vector space. It is used for constructing linear code. I think we already know the vector space. A non-empty subset C of a vector space V is called subspace of V if C is vector space under the same operation of V. And then the definition of linear combination, linear independent, and linearly dependent. And then the definition basis. And then Euclidean inner product, I think yeah. If V is V and W a vector in Fq to the n, yeah, Euclidean inner product or scalar or dot product of V and W is defined like this. Yeah. We multiply its component and then the sum of the result. And V and W are orthogonal if the inner product of V and W is 0. Let S be subset of vector space Fq over to the n, and S is not MC. The orthogonal complement or the Euclidean dual S perp of S is given by, so S perp is all of